Thanks all for attending. Just to explain, the Advanced Applications Group is a small team within Avnet where we actually build products. We're actually designing hardware, software, and the marketing material around it and the training programs that assist developers get to market quickly. So let's get into it. Very briefly, what we're going to cover, just looking at low power system design for an edge AI device. What are the goals, constraints, applications, as much as we can cover in the short amount of time that we got here. Just the, you're going to deal with some constraints, but also, how to leverage. These days you have smart sensors, you have highly functional AI devices, and the wireless connectivity aspect, just how do you minimize power consumption there? And then also, not forgetting, you need to design from the start your device security and make sure that's not impacting your power consumption as well. And then we get into a case study, which is a product we developed recently, where we have sensors, a neural processor unit, secure MCU, Wi-Fi, Bluetooth, and more. And in closing, I'll just try and revisit some of the trade-offs that I mentioned and perhaps some lessons learned in the process. So starting at the really basic level, obviously power is voltage times current, but it's much more than that. For a battery-operated application, you really want to look at it over time. Your power is not constant. Your device is doing different tasks. So certainly my approach is to try and partition what's always on, what's interrupt activated, and what activities are periodic, and start categorizing, analyzing the power in those different categories. So you absolutely need to minimize the power under the curve. You have this energy curve, obviously voltage times current, power versus time, and at the end of the day, your battery depletion is going to depend on how much you can keep that curve down. In terms of design questions, you need to look at what sensor sample rate, what is the lowest sample rate can be tolerated. So obviously, if you're doing high frequency sampling, things are on a lot of the time, you're going to be burning through that battery in no time. Also, how much processing latency is acceptable? Do you have to respond very quickly to an event? And can components sleep between events? And that's kind of what we're getting to in the table there. You want to be putting things to sleep, turning things off as much as possible.